Hello friends, this video on structure of atom part 22 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 21. So let's see the Bohr model in 1993, the postulates of that, what the Bohr model conveyed that time. So the final conclusion of the Bohr model was the electron of the hydrogen atom can move around the nucleus in a circular path, fixed radius, and they all have fixed energies, right? They are called orbits, and these orbits are arranged concentrically around the nucleus like this. The energy of the electron in the orbit does not change with time. The energy, if example, if I have electron here, it will always be the same if it is in this orbit. Electron will move from lower to higher, lower stationary state to a higher stationary state when required. Amount of energy is absorbed or emitted. For example, in this case, if it emits some energy, it will go to the lower state. If it absorbs, it will go to the higher state. And the delta is nothing but this RH written by constant by 1 minus n initial square minus n final square. And the frequency of radiation absorbed or emitted when transition occurs between the stationary states is nothing but, you see, delta E is also I can write as h mu. So mu is nothing but delta E by h. So we got frequency as delta E by h. Correct. The angular momentum of electron in a given stationary state can be expressed using this equation. mvr is nothing but nh by 2 pi, where n can have any value 1, 2, 3, 4. That's the formula for the angular momentum of electron in a particular orbit. And please note, once again I am telling the orbit concept is wrong. It doesn't exist. In real, this was just a concept by Bohr. We still study this because it makes us easy to understand the atom, because the quantum model is a little complex to understand, but still this model is incorrect. The stationary states of electrons are numbered n is equal to 1, 2, 3, and they are called principal quantum number. This is the only quantum number required at that point of time in Bohr model to uniquely define an orbit. And the radius, he also gave the formula to find the radius of the orbit, that is r is nothing but n square a0, and a0 is 529 picometer, right? So 2.9 actually. So if you see, if you put n is equal to 1, you get the radius of the first stationary state as 52.9 if you put n is equal to 1. And please note, it is stationary state doesn't mean the electron is stationary. I'll tell you, electron can never be stationary. It is not possible to have a stationary electron. It can never be stationary. Correct? And the most important property with the electron is the energy. And he also gave the formula to give the energy of its stationary state. That is, E is nothing but minus 1 by RH, 1 by R square. That's the energy of an electron in a particular orbit. So you get a lot of formulas to find the momentum, radii, energy, but still the orbit concept is wrong. And Bohr's theory can also be applied to ions containing one electron. Please note, this Bohr theory was generally for one electron. So hydrogen is fine, or any ions, for example, helium ion, lithium, plus 2 beryllium, and all, which is only one electron. Bohr theory work pretty decent for that, because it's a very simplified story of, or simplified model of the actual quantum model. And that's why we put a lot of stress on Bohr model also, because if you understand the Bohr model, it's easy to understand the quantum model. It's a very basic form of quantum model. And it is also possible to calculate the velocities of electron moving in these orbits, right? And the magnitude of velocity increase with the increase in positive charge in the nuclei and increase of principal quantum number. So if you see, what I'm saying is, if my electron or the charge is more on the atom, if you have more protons, right, more protons, the velocity will be more. if you increase the proton. If you keep the proton constant, if you go from one orbit to higher orbit, if you go to higher orbits, the velocity will be less because it decreases with increase in principal quantum number. So if you are not able to understand this, you can ignore this now, because we'll study the actual quantum model also, where we'll tell you how to find the velocity impact on the orbitals. There we have the term called orbitals, not the orbit. Here we are using the term orbit. The orbit is something which doesn't exist. Now the question is, in Bohr model of hydrogen, energy is negative. Why? So negative signs mean the energy is lower than the energy of free electron at rest. See, first thing, electron will never be at rest, right? So this is nothing but an electron which is not in effect of any charge. I can say that is the energy of electron they are talking about, that is infinitely away from nucleus. So what they are saying is, if I have an electron somewhere infinite distance here, and if I assume this guy has zero energy, the moment I take it here, it will lose some energy. It will go here, it will lose further more energy. So let's suppose if it is -5 here, it becomes -6 here, it becomes -7 here. It keeps losing energy. Why? Because it loses energy and it gives you the photon, light. That's how we have seen. If the electron jumps from higher orbital to lower orbital, it loses energy and it emits a photon. So we can't assume the energy to be zero here, right? So what we are doing is we are assuming the energy is zero at the infinite distance. Please note, we are assuming it is zero. It is not zero. We are assuming because we had to give some number. So we are assuming it is zero just for the convenience of our calculations. We are giving it zero here. And then we are telling that if you take this electron to this place, right, it will lose some energy because it will be now in, it will be slave of this proton, you can say, because it will be controlled by this proton. So it loses some energy, it goes further down the level, it loses further more energy and keeps losing energy till it's reached this n is equal to 1, the least energy state. And that's why the energy is negative, because at this point it is 0, and if it is losing energy, it has to be negative, right? It can't be positive, and that's why it is negative. Right? And that's what they are saying, when it's free from the nucleus influence, it is taken to be 0. And when the electron is attracted by the nucleus and is present in orbit n, the energy is emitted and lowered. So same thing. So you just keep going into the down level, you keep losing energy, and the max you can do is n is equal to 1. You can't go beyond this, and Bohr didn't have any explanation for this. We will have the explanation for this in the quantum model, why the electron can't go and jump into this nucleus. Just understand that why the energy is negative is because at the infinite distance we are assuming the energy is 0. When it comes to comes near the neutron, it comes to different orbits, it keeps losing energy and it goes to the lowest possible energy level, and thus since it has lost energy, it is negative. So if you see each of these spectral lines, I told the energy is quantized. Each of these spectral line is because of a movement of electron from one orbit to another. Right? Each of this spectral line signifies one movement. And also if you have large number of hydrogen atoms, then different possible transition can be observed, and that's why you'll see a lot of lines, but you'll have fixed lines only, because these lines is not possible as far as hydrogen is concerned. And the brightness of this will also depend on the number of photons. It won't depend on the frequency. It will depend on the number of photons of same wavelength. So as I told earlier, according to Bohr, the energy is absorbed. Energy is absorbed if electron moves from orbit of smaller quantum number to higher quantum. For example, from here it moves to here. So in this case, energy is absorbed. And if it is going from higher to lower, energy is emitted. If you see, energy is emitted, right? So I'll say energy is absorbed. Here energy is emitted, and this energy gap is nothing but E final minus E initial. And I told that every orbit has energy defined. Bohr has defined that also. Every orbit, whatever the energy orbit will have, he has defined that, so we can find delta E easily. Correct? And that gives the line spectrum, because we can have only fixed set of delta E, and fixed set of delta E will be corresponding to fixed set of lambda, and fixed set of lambda will means we have fixed set of spectra. Correct? For stability of atom, Bohr gave an explanation that in a particular orbit, energy is conserved. If you take electron anywhere in this orbit, it will have same energy. And since he is telling that the electron is moving in the same orbit, it is not losing energy. Since the energy is not lost, it is moving with a particular velocity. There is no friction there, so it just keeps moving in the same orbit. The concept he told was there is energy is same for any electron in a particular orbit. Only when the electron jumps from a higher orbit to lower orbit, it emits energy, or when it jumps from lower to higher energy, it needs some energy. So that energy change is required only when there is a jump of electron from orbit A to orbit B. But if it is in vertical orbit, the energy is constant, and that's why it's saying that it keeps moving. But still, I don't find the answer to be very convincing. The quantum model gives a better explanation to this. We'll understand this when we discuss the quantum model. So Bohr model has a lot of limitations. So Bohr model has a lot of limitations. The first is it was mainly for hydrogen. The second is it could not explain the spectra of multi-electron atoms. It could explain the spectra of hydrogen atoms very well, but it could not explain the spectra of multi-electron atoms. And also he assumed electrons as a charged particle. So the wave character was ignored. As I told, right, the duality principle of electrons were in fashion that time, but he ignored that completely, and he considered electrons only as particle, and it was not able to explain the ability of atoms to form molecules by chemical bonds. And it contradicts with the Heisenberg uncertainty principle. That's a very strong principle at that point of time. And the G-Man effect that is there when we see the deviation in the spectral line due to magnetic field, that could not be explained. Also the Stark effect, that is nothing but change in spectral line due to electric field, that also could not be explained. We'll talk about G-Man and Stark effect later also. And the Schrödinger equation came out after the Bohr model, and that gave a better explanation of distribution of electron in the space, and gave equation for different orbitals. So actually Schrödinger equation gave a better explanation of the atom than Bohr's. So Bohr become an obsolete model, and Schrödinger's quantum model becomes the popular model. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.